everyone, welcome back to my channel. I built this super simple robotic gripper. So this is meant for beginners to learn about robotics and motion control. And the best part about this is you can build one at home, even if you have never built a robot before.
This is my DIY robotic gripper. It runs on a servo motor controlled by a Raspberry Pi with 3D printed gears doing the heavy lifting. In this video, I will show you how to design, print, wire, and code the whole thing. And we will test it on some very scientific objects, like my super rubber duck. Alright, let's build this thing step by step. Feel free to pause anytime and follow along. I wanted to make a really simple gripper, something beginners can easily build to get started with robotics. To keep things straightforward, I went with a direct drive setup using an SG92R servo motor. This is one of my favorite servo motors for small projects. For designing the gripper mechanism, I grabbed a basic plastic gear model from the McMaster car website. Then I added a small finger shape onto it. The key is making sure the right gear is rotating relative to the left one so that the teeth match properly. For the pivot axis, I just used a screw as the shaft for the left gear. And for the right one, I connect the printed gear directly onto the servo motor shaft. Both are mounted on a simple base plate. Mechanical design rarely works perfectly the first time, and that's totally fine. What matters is starting, testing, and improving. That's why 3D printing is perfect for projects like this. It's very quick to prototype and very quick to fix, and you can improve. Once the design is ready, it's time to 3D print the gears and the base. I designed everything in Onshape, and you can grab the parts straight from their website, or you can download the STL files using the link in the description below. Feel free to reuse and adapt the design to your needs. Maybe tweak the size or change the shape to fit the objects that you want to grasp. That's the fun part of building stuff like this. Once you've got the STL files, open them in your 3D printing slicer. I'm using Ultimaker Cura for slicing, and my 3D printer is a Calibrate Ender-3 V2 Neo. If you'd like me to dive deeper into 3D printing basics, just drop a comment below. After slicing, save the G-code to your SD card, put the card in the printer, and you are ready to go. Alright, let's start the print. That's everything you need to start putting it together. Here are the printed parts. They turned out pretty nice. Now let's go ahead and start assembling the gripper. First essential parts are the 3D printed parts for the gripper mechanism. We will also use an SG92R servo motor to drive the gripper. The brain of this project is the Raspberry Pi 4B. We'll use a PCA 96585 module to control the servo motor with the Raspberry Pi. We will also need some hardware, especially M2 screws, nuts, and washers for assembly. To help with the assembly, we will need a screwdriver and an Allen key. Finally, we will need some jumper wires to connect the components. To start assembling, first place the nut into the slot on the motor base. This is very important because later the hole will be very hard to access due to the servo body. Then mount the servo motor onto the base using two M2 by 12 screws. Feel free to go back to the CAD drawing to get the right orientation of the servo motor. Then attach the left finger with the M2 by 16 screw. Try to not tie this screw too much. The gear should be able to spin freely. Otherwise, too much friction may overheat the servo. After, I put the motor shaft in the right finger, and I attach the right finger using 2 screws provided by the servo motor. Make sure to put the nut into the motor base first. That's really important. Once the servo is mounted, it's almost impossible to fit the nut into place afterwards. Now the assembly is done. Let's wire everything up. You will find the wiring diagram in the description below. First, I connected the servo motor to the PCA9685 motor driver board by plugging the 3 servo wires, orange to PWM0, red to V+, and the brown to ground. Next, I connected the Raspberry Pi to the motor driver board using 4 jumper wires, 3.3 volt to VCC, ground to ground, SCL to STL, and the SDA to SDA. Finally, I connected the external power supply to the motor driver board with 2 wires. This step is super important. Without external power, the servos can draw too much current, and this may cause a burnout, and that might crash or even damage your Raspberry Pi. For this project, I'm using Raspberry Pi instead of Arduino because it gives me more flexibility. It can easily interface with a wide range of actuators and sensors, including servo motors and RGB cameras. Once everything's wired up, we just need to make sure I2C is turned on in the Raspberry Pi. I did it through Pi's desktop setting. It's super easy. Just open Raspberry Pi configuration from the main menu, head over to the interface tab, and switch I2C to be enabled. After that, give your Pi a quick reboot and you are good to go. Next, let's make a folder for your servo control code. Inside that folder, create a new Python file. You can just grab the example code from the link in the description. It's a simple script that uses Adafruit library to control the servo. I'm using Thonny editor, but feel free to use whatever works best for you. I like it because it's clean, easy to debug, and perfect for small projects like this. Once your code is ready, just hit the play button. This code makes a servo gripper open and close again and again. A servo is a small motor that can move to specific positions, like 0 degree or 45 degrees. First, in this code, we import the time and the servo libraries. Then, we create a servo controller with 16 channels. We choose channel 0 for this gripper because that's how we wired it up. After that, we calibrate the servo so that it moves correctly. Finally, the program opens the gripper, waits, then it closes it, waits again, and repeat this like 10 times. When you run this for the first time, it is not going to work directly. The gear rotation may be blocked. You can even feel the servo motor heat up if it lasts too long, or making crazy noise like this. This is because the range values of PWM and the servo angle commands are not properly set. PWM is like a message sent to the servo. The message is not the angle itself, but the pulse width. A shorter pulse moves the servo to one side, a longer pulse moves it to the other side. And we must calibrate those values so the mechanical gripper positions match the code. So, how do I calibrate a servo motor? First, I unscrew the left finger so the right finger can move freely. That way, the servo doesn't get blocked and overheat. Then, I test the 0 degree and 90 degree positions of the right finger to understand the starting point and the full range of motion. From there, I can adjust the pulse width values to fine-tune how far the gripper opens and closes. Once I've found the right range, I unscrew the right finger and set it to 0 position. Then I do one last test to check the gripper open and the close positions. By adjusting the angle value, I found that 45 degrees is the closed position for my gripper. 0 degree is a fully open position. That might be different for your build depending on how you mounted the fingers. Finally, I screw the left finger back in place and there we go, it works! So, time for the ultimate test. Can it grab the pocket tissue? The tape roll? The screwdriver? Or my trusty rubber?
That's how I built this beginner-friendly robotic gripper. So if you liked the video, please give me a like and feel free to share about what you built and what you tried to pick it up with this gripper on the comment section. See you next time!